Welcome to Johnny Discovery. Today we're taking you on a fascinating journey into the world of cucumber pickles, a journey that begins on sun-kissed farms and ends with the crispy, tangy delights we love in jars. Whether you call them pickles, gherkins, or brined cucumbers, there's no denying their crunchy charm. Have you ever wondered how these flavorful treats go from tiny seeds to store shelves around the globe? Let's explore the complete farm-to-factory process of cucumber pickling. The large-scale production of cucumbers requires meticulous planning, advanced farming techniques, and efficient harvesting methods. Cucumber farming has evolved over the years, with modern agricultural practices allowing for higher yields and improved quality. From selecting the right seeds and preparing the land to managing pests, irrigation, and fertilization, farmers employ a wide range of strategies to ensure a successful harvest. Furthermore, technology has significantly improved the efficiency of cucumber farming, making large-scale production possible. Cucumbers hold a significant place in U.S. agriculture, contributing to the economy and fulfilling the dietary needs of millions of people. They are consumed fresh, used in salads and sandwiches, and processed into pickles, making them an indispensable part of the food industry. The popularity of cucumbers has led to an increase in large-scale farming, ensuring their availability throughout the year. Slicing cucumbers, the long, smooth-skinned types found in supermarkets, typically range from 6 to 9 inches in length. These are bred for fresh consumption, favored for their mild flavor and refreshing crunch in salads, sandwiches, and spa waters. Pickling cucumbers, on the other hand, are smaller, usually ranging from 3 to 5 inches in length. They have a bumpy, textured skin and a more robust flavor, making them perfect for pickling. Michigan and Wisconsin are major producers of pickling cucumbers, supplying large food processing companies that manufacture pickles for both domestic and international markets. Greenhouse cucumbers are another important variety, often grown using hydroponic systems. These cucumbers are typically seedless, with thin skin, and are popular in high-end grocery stores and restaurants. The controlled environment of greenhouses ensures consistent quality and year-round production, reducing dependence on seasonal fluctuations. In the U.S., cucumbers are primarily grown in states like Florida, California, Michigan, Georgia, North Carolina, and Texas, regions blessed with warm climates and fertile soils. The success of cucumber farming begins with proper land preparation. Farmers carefully select and prepare their fields to ensure optimal growing conditions. Cucumbers thrive in well-drained sandy loam soil with a pH between 6.0 and 7.0. Soil rich in organic matter is essential for healthy plant growth, as it provides the necessary nutrients and retains moisture. The land preparation process involves several steps. First, the fields are plowed and tilled to break up compacted soil, improving aeration and drainage. Organic matter such as compost or manure is added to enhance soil fertility. Farmers then apply fertilizers, particularly phosphorus and potassium, to support root and vine development. Many large-scale farms use plastic mulch on the soil surface to retain moisture, suppress weeds, and regulate soil temperature. These practices ensure that cucumber plants receive the best possible start for a high-yield harvest. Cucumber farming begins with the selection of high-quality seeds that are resistant to diseases and pests. Farmers typically use hybrid seeds, which have been developed for better yield and resilience. Using advanced semi-automatic planting machines, modern cucumber farming begins with the precise sowing of cucumber seeds. Each seed is placed at just the right depth in the soil by these specialized machines to ensure healthy growth. Once planted, the seeds are regularly attended to so they can sprout into beautiful young plants. Cucumbers are planted when the soil temperature is above 60 degrees Fahrenheit, ensuring optimal germination. Seeds are typically spaced 12 to 24 inches apart in rows that are 3 to 6 feet apart, allowing sufficient room for vine growth. Proper spacing is crucial to prevent overcrowding and ensure good air circulation, reducing the risk of disease. Cucumbers require a consistent supply of water to thrive. Proper irrigation is essential to prevent bitterness and ensure uniform growth. Most cucumber farms in the U.S. use efficient irrigation systems to manage water distribution. Drip irrigation is the most effective method, delivering water directly to the roots of the plants, reducing water wastage and minimizing disease risks. Sprinkler irrigation is also used, especially in large fields, as it ensures even water distribution. In some regions, furrow irrigation is employed, where water is channeled through small trenches between rows of plants. Cucumbers require about 1 to 1.5 inches of water per week, and during hot summer months, farmers increase irrigation frequency to maintain adequate moisture levels. Efficient water management is crucial, as both overwatering and underwatering can negatively impact plant growth and yield. As the plants grow, they develop sprawling vines and produce bright yellow flowers, early signs of the bounty to come. Farmers frequently monitor the plant's health, checking for pests, diseases, and signs of maturity. During this flowering stage, pollination becomes crucial, and nature lends a helping hand through bees. Bees' diligent pollinators are drawn to the cucumber blossoms by their vibrant color and sweet nectar. As bees move from flower to flower, they transfer pollen, especially from male to female blooms, triggering the fertilization process necessary for fruit development. To ensure successful pollination and maximize yield, many farmers even place beehives near the fields, creating a buzzing ecosystem where cucumbers and bees thrive together. Cucumber harvesting is a crucial stage that determines the quality and market value of the crop. The timing of the harvest depends on the type of cucumber being grown. Slicing cucumbers are typically harvested when they reach 6 to 9 inches in length. Pickling cucumbers are picked at a smaller size, around 3 to 5 inches. If left on the vine too long, cucumbers can become overripe, turning yellow and developing a bitter taste. In the past, harvesting cucumbers was entirely manual, a labor-intensive task that demanded hours under the hot sun. But today, technology is transforming the way cucumbers are harvested. Most large-scale cucumber farms use a combination of manual and mechanical harvesting methods. In smaller farms, workers manually pick cucumbers, carefully selecting the ones that have reached the ideal size and color. Cucumbers grow rapidly and must be harvested frequently, sometimes every day or every other day. In large commercial farms, mechanical harvesters equipped with conveyor belts and sorting mechanisms are used to pick, clean, and sort cucumbers in seconds. Mechanical harvesting is particularly common in the pickling cucumber industry, where large quantities must be harvested quickly and efficiently. Freshly picked cucumbers are carefully transferred into large bins and field trailers, designed to protect their delicate skin and preserve freshness during transport. These containers are positioned directly alongside the harvesters, allowing for a seamless flow from vine to bin without delay. Field workers and operators gently load the cucumbers, ensuring minimal bruising or damage. Each bin can hold hundreds of pounds of cucumbers, and once full, they are quickly hoisted onto flatbed trucks or specialized transport vehicles. Time is of the essence, as maintaining the cucumber's crisp texture and natural moisture is crucial for the next stage of processing. At the first stop, cucumbers undergo an essential cleaning phase. Powerful water jets wash each cucumber, removing all the dirt and debris on their skins without damaging their quality or appearance. Afterward, the cucumbers undergo a meticulous sorting process, each one evaluated for size and quality, before being transported to factories equipped with specialized production lines, where they begin journey to your table. High-quality slicing cucumbers are packaged for grocery stores, while lower-grade cucumbers may be used for processed foods. For pickling cucumbers, the next step is brining and fermentation. These cucumbers are submerged in salt water or vinegar solutions and stored in barrels for a specific period, allowing them to develop the signature tangy flavor of pickles. Large food processing companies handle this stage, producing pickles in various flavors and styles to cater to consumer preferences. Once the cucumbers arrive, they're unloaded onto conveyors and pass through another round of cleaning and inspection. Then comes the heart of the operation, the brining stage. brining is the magic that turns ordinary cucumbers into extraordinary pickles. In large industrial vats, cucumbers are soaked in a brine solution made of salt, water, and a secret mix of spices. Each company uses its own signature blend, often including dill, garlic, mustard seeds, bay leaves, peppercorns, and vinegar, to create their unique flavor. The brining process can last anywhere from 1 to 4 weeks, depending on the desired flavor, crunch, and preservation. During this time, conditions such as temperature, salinity, and humidity are meticulously controlled to ensure consistent quality. After brining, the pickles are drained and transferred to the packing line. Old pickles are carefully sorted by size and quality, then funneled into sterilized glass jars. Automated arms or skilled workers ensure that each jar is filled uniformly, maintaining both visual appeal and product consistency. Next comes the addition of pickling brine, a seasoned solution of vinegar, water, salt, and spices, poured hot into the jars to preserve flavor and extend shelf life. As the final step, lids are tightly sealed, and the jars pass through a heat-based vacuum sealing process to ensure safety and freshness. Some companies use fast-track pickling methods, placing cucumbers directly into sterilized jars with brine and spices, then sealing and stacking them in fermentation chambers for rapid pickling. This method is ideal for sliced or deli-style pickles that need quicker turnaround. For sliced pickles, automated cutting machines turn full cucumbers into thin, uniform slices. These are loaded into glass jars, followed by a fresh pour of the pickling solution to keep them preserved and tasty. Workers double-check each jar for quality and quantity, ensuring every product looks as good as it tastes. After sealing, the jars are passed through a heating or pasteurization tunnel to extend shelf life. Finally, they're labeled, packaged, and stacked onto pallets, ready to be shipped to consumers and adding flavor to delicious meals around the world. Pickles, especially those made through natural fermentation, are rich in probiotics, good bacteria that aid digestion and support a healthy gut. They're hydrating, low in calories, and full of antioxidants. Plus, the vinegar in pickles can help regulate blood sugar levels, while the dietary fiber in cucumber skins promotes regularity. With their tangy, refreshing crunch, pickles make an excellent side dish, enhancing your meal. From planting tiny seeds to brining in massive vats, the journey of the cucumber pickle is a stunning example of agricultural innovation and culinary tradition. The love and technology behind every jar are what make pickles a global favorite. If you enjoyed learning about this process, don't forget to hit that like button, share this with your foodie friends, And subscribe to Johnny Discovery for more behind-the-scenes looks into the world of food, farming, and factories. Did you know that onions are more than just a kitchen staple? These versatile bulbs are at the heart of countless dishes worldwide, and the United States plays a leading role in their production. Imagine fields stretching for miles, with rows of onions soaking up the sun, destined to flavor meals across the globe. The U.S. produces a staggering 3.2 billion pounds of onions annually, ranking among the world's top producers. This impressive output reflects the dedication and precision of American farmers who have mastered the art of onion cultivation. Onions are not just crops, they're a testament to the innovation and hard work behind modern agriculture. With this foundation, let's dive deeper into the fascinating journey of onions, from seed to plate, and uncover how the U.S. continues to set the standard for excellence in onion farming. The first step in planting onions is choosing the right land. Farmers look for well-drained sandy loam soil with a pH of 6.0 to 6.8, which provides the perfect environment for onions to thrive. Fields are carefully prepared with deep plowing, leveling, and the addition of organic matter to enrich the soil. This ensures that onion roots have access to the nutrients and aeration they need for optimal growth. Onions can be planted in three main ways: seeds, transplants, or small bulbs. Seeds, the cornerstone of large-scale operations, are directly sown into the soil, offering simplicity and cost-effectiveness. For those looking to speed up growth and ensure uniformity, especially in cooler climates, transplants and small bulbs are the perfect choice, giving farmers a head start on the growing season. Across the United States, farmers strategically align their planting schedules with the seasons to ensure optimal growth and harvests. In the southern states, where winters are mild and forgiving, farmers plant onions in the fall. These onions thrive in the cool months, ready to be harvested by spring, just as the rest of the country starts craving fresh produce. Meanwhile, in the northern states, the approach is different, but equally precise. Here, farmers plant onions in the spring, taking advantage of the warmer growing season to nurture their crops. By late summer, these onions are ready for harvest, adding to the national supply just as the southern harvest winds down. This staggered planting schedule is a masterpiece of agricultural planning. It ensures a steady stream of fresh onions throughout the year, bridging the gap between regions and seasons. From fall planting in the south to summer harvests in the north, this seamless coordination highlights the ingenuity and adaptability of American farmers. California, the leader in U.S. onion production, showcases the benefits of this meticulous planting process. Its fertile soils and consistent climate allow the state to contribute nearly 30% of the nation's onion output, a testament to the power of preparation and expertise. What separates a good onion from a great one? The answer lies in the care it receives during its growing journey. From ensuring the right amount of water to defending against pests and diseases, caring for onion crops is a meticulous process that demands both expertise and dedication. For U.S. farmers, this stage is where their efforts truly shine, transforming fields into bountiful harvests. Did you know that onions are about 89% water? This makes consistent irrigation crucial for their development. Farmers carefully provide 20 to 30 inches of water per growing season, tailoring irrigation schedules to soil type and weather conditions. Drip irrigation systems are widely used, delivering water directly to the root zone while conserving resources and minimizing disease risks. The effort farmers put into caring for onion crops pays off with impressive yields. On average, U.S. farmers harvest 40,000 to 60,000 pounds of onions per acre, with Washington State achieving some of the highest yields due to its fertile soils and precise irrigation methods. Harvesting onions isn't just about pulling them from the ground, it's a finely tuned science of timing and technique. Every step is deliberate, aimed at preserving the onion's peak quality and ensuring it lasts as long as possible. Farmers rely on a key natural signal. When 50 to 80% of the onion tops have fallen over, it's a clear indication that the bulbs have stopped growing and are ready to be harvested. This subtle but significant change marks the perfect moment to act. The timing of this process depends on the variety of onion being grown. Some onions reach maturity as early as 90 days after planting, while others require up to 150 days. Each variety has its own rhythm, and farmers monitor their fields closely to pinpoint the ideal harvest window. This precision is crucial, not too early, not too late, to ensure that the onions boast maximum flavor, firmness, and storage potential. Harvest too early, and the onions may be underdeveloped. Wait too long, and they risk rot or damage. By paying close attention to weather conditions and crop maturity, farmers ensure they catch the harvest window just right. The journey of harvesting onions begins with sophisticated machinery designed to handle the delicate task of lifting the crop from the soil. Windrowers, mechanical marvels used in onion harvesting, play a vital role in loosening the soil around the onions and gently lifting them from the ground. The design of windrowers ensures that the onions are not damaged during this process. With adjustable blades, they can cut through the soil and lift the onions smoothly, preventing any bruising of the delicate bulbs. Once lifted, the onions are arranged in neat rows called windrows, where they are left to cure in the sun. This natural curing process allows the onions to dry their outer layers, preparing them for long-term storage. This typically takes 7 to 10 days, depending on the weather. Farmers monitor curing conditions carefully, as excessive moisture can lead to spoilage. After a few days of sun exposure, the onions are ready to be gathered. This is where the onion harvester comes into play. These specialized machines scoop up the onions from the windrows, carefully separating them from any remaining soil and debris. The harvested onions are then transported up a conveyor belt, where they are cleaned and sorted. During this process, the harvester gently removes dirt and loose skins, leaving the onions looking shiny and fresh. In some advanced harvesters, built-in grading systems sort the onions by size right in the field, improving efficiency. Onions are carefully transported from the fields to processing factories, where the first crucial step involves unloading them into large receiving bins. From these bins, the onions are transferred onto conveyor belts that guide them through the initial cleaning phase. The cleaning process is highly efficient, thanks to conveyor belts specifically designed with perforations that allow smaller debris and soil to fall through, while the onions remain on top. This design ensures that only the onions make it through the next phase of cleaning. High-pressure air blowers and rotating brushes are then used to further clean the onions, removing any remaining dirt and loose outer skins. This step ensures that the onions are as clean as possible before moving on to further processing stages. Once the onions are cleaned, they proceed to the sorting and grading section of the factory. Here, automated sorting machines equipped with optical sensors come into play. These machines categorize onions based on size, shape, and quality, with the ability to detect defects. onions that don't meet the quality standards are separated, ensuring that only the best ones continue down the production line. Once onions are peeled, they move on to the final stages of processing, where they are cut into various shapes and sizes based on their intended use. Some are diced for frozen food products, while others are sliced into rings or pieces for prepackaged meals. These different cuts cater to the varying needs of consumers and food manufacturers, ensuring that each onion is tailored to its final application. The next step in the process is packaging. After being cut and sorted, the onions are packed into bags, boxes, or containers. Proper packaging ensures that the onions are protected during transport and storage, keeping them fresh until they reach consumers. As consumers, it's important to recognize the journey behind each onion, from the careful attention it receives in the field to the meticulous processing and distribution systems that bring it to our kitchens. The future of onion farming lies in the continued adoption of sustainable practices that balance productivity with environmental stewardship. Every year, American farmers harvest millions of tons of onions, employing state-of-the-art technology to make the process smooth and efficient. Behind every onion is a story of precision, dedication, and innovation, showcasing the hard work of farmers and the marvels of modern agriculture. So the next time you slice into an onion and feel your eyes well up, let it remind you of the incredible journey that onion has taken, from the soil to your table. Think of the hands and innovations behind it, and savor not just its flavor, but the dedication that brought it to your plate. That tear might just be a testament to the extraordinary tale of one of the world's most beloved ingredients. Welcome to Johnny Discovery, where we explore the fascinating world of modern agriculture across America. We're diving deep into one of the sweetest stories in farming, the journey of sugarcane, from soil to spoon and from sprawling fields to high-tech sugar mills across the United States. Today we'll explore vast sugarcane farms in the U.S. We'll follow the farmers from planting to harvest, learn about modern farming technologies, and understand the sugar production process in factories. Let's get started. Before a single stalk of sugarcane can rise, the land must be carefully prepared. Farmers in Florida, Louisiana, and Texas, the key sugarcane growing states, start by clearing fields, plowing the soil, and testing for pH, nutrients, and organic matter. The timing of sugarcane planting varies by region. In Florida and Texas, it starts in late summer, while in Louisiana, it typically occurs between August and October. After each growing season, sugarcane fields undergo significant wear and nutrient depletion. To restore optimal growing conditions, farmers initiate a thorough soil preparation process. This begins with deep tillage, a crucial step that not only aerates the soil, but also breaks up compacted layers, enhancing both drainage and root penetration. Using high-powered tractors paired with specialized plowing equipment, farmers can till several hectares per day, transforming hardened soil into a loose, crumbly medium, ideal for sugarcane root development. Next comes the precise formation of planting rows. On large-scale sugarcane farms, straight and evenly spaced rows are essential, not only for efficient crop management, but also to accommodate mechanical harvesters. Farmers employ GPS-guided machinery to carve parallel furrows into the soil. These furrows typically follow the contour of the land to reduce erosion and maximize water retention. These furrows are more than just grooves. They're the cradles for new sugarcane life. Sugarcane is propagated using sections of mature cane stalks, known as cane sets. Each cane set is cut to a length of approximately 12 to 18 inches, containing 3 to 4 viable buds, the nodes from which new shoots and roots will emerge. These pieces are placed into the prepared furrows by a mechanized sugarcane planter, which ensures even distribution and depth. Each piece containing 3 to 4 buds is laid horizontally or slightly inclined into the furrows at a depth of 1 to 1.5 meters, depending on soil conditions. The machine then gently backfills the furrow, covering the cane sets with a layer of soil to protect them from desiccation and to maintain adequate moisture levels for germination. This mechanized process dramatically reduces labor intensity and improves planting accuracy. From the moment those buds sprout, sugarcane begins a long and steady journey of growth, typically lasting 12 to 18 months. The growth process is divided into 3 main stages: germination, tillering, when new shoots form, and ripening, when the cane stalks swell with juice. Sugarcane is classified as a water-intensive crop, requiring substantial moisture throughout its life cycle, especially in the first 3 months when roots and shoots are establishing themselves. Without adequate water, plant development slows dramatically, leading to reduced yields. To address this need, farmers employ a variety of modern irrigation techniques tailored to the specific topography and climate of the farm. The 3 most common methods include drip irrigation, sprinkler irrigation, and flood irrigation, with drip systems being the most prevalent in high-efficiency operations. Drip irrigation is widely adopted on modern sugarcane farms for its exceptional water use efficiency. This system consists of a network of main water lines branching out into smaller, flexible tubes that run alongside each row of sugarcane. Attached to these tubes are emitters, small nozzles placed at regular intervals, strategically positioned near the root zones. Installing a drip irrigation system in a sugarcane field is a smart investment in both productivity and sustainability. The process begins with careful land preparation. Farmers level the field and plow the soil to create optimal conditions for root development and water absorption. Once the field is ready, a reliable water source is connected to a powerful pump system, which channels water through a sophisticated filtration unit, which removes any impurities before the water reaches the crops. Then, main pipelines are laid out across the field, branching into thin drip lines that run alongside each row of sugarcane. Each line is equipped with small emitters that release water slowly and precisely at the root zone. No waste, no runoff. This method not only saves up to 60% of water compared to traditional methods, but also reduces weed growth, minimizes disease pressure, and enhances crop yield and quality. Another effective method, particularly in large or irregularly shaped fields, is sprinkler irrigation. In this setup, high-pressure pumps push water through pipelines to sprinkler heads spaced evenly across the field. These heads distribute water in a circular pattern, simulating rainfall. Sprinkler systems are highly adaptable and can be moved or adjusted to suit the crop's stage or field conditions. While slightly less efficient than drip systems in arid climates due to evaporation, sprinkler irrigation remains popular because it can cover vast areas quickly and uniformly. Flood irrigation is one of the oldest and most widely used methods in sugarcane farming. After preparing the field with level furrows, water is released from canals or ditches and allowed to flow across the rows, soaking the soil thoroughly. This method is simple, cost-effective, and ideal for flat terrains with abundant water supply. Though less precise than modern drip systems, flood irrigation delivers large volumes of water quickly, supporting rapid growth during the crop's early stages. When managed properly, it can still produce healthy yields with minimal infrastructure. Equally vital to sugarcane development is fertilization, as this crop requires large quantities of nutrients to support its tall stalks and dense biomass. The essential macronutrients for sugarcane include nitrogen, N, for leaf and shoot growth, phosphorus, P, for root development and early maturity, and potassium, K, for enhancing sugar content and disease resistance. In addition to water and nutrients, young sugarcane must be protected from weeds, which compete for sunlight, water, and soil nutrients. To address this challenge, farmers rely on precision herbicide application using advanced spraying equipment. By eliminating weed competition early on, farmers give sugarcane the best possible start, promoting stronger root development and more vigorous growth throughout the season. Once the sugarcane has reached full maturity, typically 10 to 16 months after planting, it enters a critical stage, harvesting. This process marks the beginning of the transformation from raw stalks into refined sugar, and it must be carried out swiftly and efficiently to preserve the crop's quality. In some areas, like Louisiana, fields are still burned before harvest to remove dry leaves and make the job more efficient. Dry leaves and weeds can cover the sugarcane stalks, obstructing machinery and slowing down the harvesting process. The fire burns off the outer leaf layer, leaving behind clean stalks and reducing the volume of unnecessary material to transport. This not only saves costs and time, but also makes the milling process at the factory more efficient, as it focuses on the sugar-rich stalks. However, this method is currently under strict regulation due to its contribution to air pollution and environmental impact. Burning sugarcane has almost disappeared because modern machines can now harvest sugarcane with minimal human intervention. Modern sugarcane harvesting is no longer the labor-intensive process it once was. Today, highly sophisticated harvesters are employed, designed to maximize yield and minimize crop loss. These machines are equipped with GPS navigation, precision cutting mechanisms, and automated cleaning systems, all working in seamless coordination. First, the sugarcane harvesters are precisely adjusted to cut as close to the ground as possible, ensuring that the entire sugar-rich stalk is harvested. As the harvester moves along the sugarcane rows, its sharp blades continuously operate, neatly cutting each cane at the base and lifting the stalks onto an automated conveyor belt. The harvester strips away the non-essential biomass, including dry leaves and leafy tops, using internal fans or rotating brushes. These byproducts are not wasted. Instead, they are returned to the field, forming a natural mulch that enhances soil fertility and moisture retention. After cleaning, the long stalks are mechanically chopped into shorter, manageable segments, usually around 30 to 50 centimeters in length. These cut sections are funneled into a storage chamber within the harvester. Once full, the machine uses an automated offloading system to transfer the chopped cane into waiting transport vehicles, typically trucks stationed along the field margins. The harvested cane is immediately loaded onto large trucks and shipped to nearby sugar mills. Why the rush? Because once cut, the cane begins to lose sugar content rapidly. Processing needs to happen fast, usually within 24 to 48 hours. As soon as the freshly harvested sugarcane arrives at the factory, the cleaning process begins swiftly to preserve the cane's natural sweetness and prepare it for juice extraction. Massive conveyors unload the cane and direct it toward high-powered washing stations. Here, powerful water jets blast away mud, leaves, and any remaining field debris. This initial cleaning is essential, not only to ensure the purity of the juice, but also to protect the crushing machines from damage caused by stones or soil. After the sugarcane is cleaned and ready, it is delivered to the crushing system inside the factory. Here, the stalks are fed into massive steel mills that press them with incredible force, extracting the sweet juice hidden within. As the canes are crushed, they release a flood of raw juice while leaving behind dry, fibrous residue known as bagasse. To ensure maximum extraction, the crushed cane goes through multiple roller sets. Water is sprayed in during this phase to rinse out every last bit of sugar from the fibers. The juice is collected below and rushed off to the next processing stage, while the leftover bagasse is whisked away, ready to be turned into biofuel or biodegradable materials. Once the raw juice is extracted from the sugar cane, it contains not only sugars but also impurities like soil particles, fibers, waxes, and organic acids. To transform this murky liquid into crystal clear syrup, the factory begins a critical purification step: lime treatment, also known as liming. In this process, the raw juice is heated to around 158 degrees Fahrenheit and then carefully mixed with milk of lime, a suspension made from calcium hydroxide. This alkaline solution helps neutralize natural acids in the juice and raises its pH level to an optimal range. As the lime reacts with impurities, it causes many of them to coagulate and form larger particles. The juice then flows into large clarifiers, where the solid particles slowly settle to the bottom as sediment, forming a thick sludge. The clarified juice, now significantly cleaner and lighter in color, is skimmed off the top and sent forward in the production line. This crucial stage not only removes unwanted materials, but also stabilizes the juice, setting the foundation for high-quality, food-grade sugar. Next comes crystallization. By adding seed crystals and carefully managing heat and vacuum pressure, the sugar in the juice begins to form into crystals. These are spun in centrifuges to separate them from molasses. After the initial extraction and crystallization, sugarcane yields raw sugar, coarse, off-white crystals that still contain impurities like molasses and natural colorants. To transform this into the pure white sugar used in kitchens and food production, a precise decolorization process is essential. First, the raw sugar is dissolved in boiling water at around 80 degrees Celsius, forming a thick syrup. This solution is then filtered through layers of sand and gravel to remove suspended solids and organic residues. However, the key step in achieving the brilliant whiteness lies in activated carbon treatment. The syrup is passed through columns filled with activated carbon, a highly porous material that absorbs color pigments, polyphenols, and residual impurities through physical attraction. Once the solution is nearly colorless, it undergoes another round of evaporation and controlled crystallization. The resulting sugar crystals are then spun in high-speed centrifuges to separate them from the remaining liquid and eliminate any lingering color or moisture. The final product is clean, dry, and sparkling white sugar with over 99.9% sucrose purity, ready to be packaged for consumers. This entire process, from raw syrup to refined sugar, reflects a seamless blend of modern engineering and food science, ensuring not only visual appeal but also consistent quality and safety in every grain. Sugar is packaged in a variety of formats, each tailored to fit different needs and uses. Large industrial sacks, ranging from 25 kilograms to over a ton, are commonly used in factories, commercial kitchens, and for export. Medium-sized bags, usually between 1 to 5 kilograms, are the go-to option for households, ideal for everyday cooking and baking. Meanwhile, mini-sized sachets are perfect for cafes, restaurants, and on-the-go use. After the juice is extracted from sugarcane, what remains is a fibrous byproduct known as bagasse. Rather than being discarded, this material is now recognized for its exceptional versatility, especially in the production of biodegradable alternatives to plastic. Bagasse is first thoroughly cleaned to eliminate residual sugars and impurities, then mechanically and thermally processed into a soft, moldable pulp. This pulp is poured into high-pressure molds to form durable and compostable items such as plates, bowls, cups, and takeout containers. These products not only serve as eco-friendly alternatives to single-use plastics, but are also fully biodegradable and compostable, often breaking down within 60 to 90 days under industrial composting conditions. This innovation contributes significantly to reducing the environmental footprint of food packaging. Beyond its environmental role, sugarcane bagasse also plays an important part in agriculture as a source of livestock feed, particularly for cattle. In its raw form, bagasse is coarse and indigestible, but when fermented, much like silage made from corn, it becomes a palatable and nutritious feed. For farmers, using fermented bagasse reduces dependency on conventional feeds and lowers overall feed costs, making it a practical and sustainable solution in livestock management. In both environmental and agricultural contexts, sugarcane bagasse exemplifies how agricultural byproducts can be transformed into valuable, sustainable resources. The US might not be the top global producer of sugarcane, but it's one of the most efficient and environmentally conscious. Florida alone produces over 2 million tons of raw sugar annually. The industry contributes billions of dollars to local economies and supports thousands of American jobs. If you enjoyed this deep dive into sugarcane farming and production, don't forget to like, share, and subscribe to Johnny Discovery. Join us next time as we uncover more behind-the-scenes stories from the world of agriculture.